Hi, this is AP Chemistry, free response question 2005, letter D. It involves both energy and electrochemistry. Let's solve them both. I'll do the entire thing and then we'll take a look at the answer. I'll use the strategy of trying to figure it out as we go. Okay, we've got some silver nitrate dissolving. Fine. In water. It's aqueous. And they say the dissolving is represented by the equation above. Yeah, I figured that out. Is the free energy for this positive, negative, or zero? Well, dissolving, such as this, happens spontaneously, so it will be negative. Is the entropy for the dissolving positive, negative, or zero? One thing turns into two, randomness is increasing, the entropy will be positive. Letter C. The solubility will increase with increasing temperature. So more dissolves as you apply heat. That means heating helps. That means it's endothermic. So delta H will be positive. Are all these things consistent? Yes. Delta G equals delta H minus T delta S. So it is possible for delta G to be negative, even though delta H is positive, because delta H is also positive, and since it's minus T delta S, it could become spontaneous, especially as temperature is increased. So yeah, it seems reasonable to me. Second part. The compound sodium iodide also dissolves in pure water, and there you go. Some of the information in the table of the standard reduction tables below can be helpful in answering the questions. I don't see just sodium iodide dissolving. This looks like the chemical reactions are occurring. So are they trying to mislead us? What's the deal? They're taking an electric current and applying it to sodium iodide. Chemistry is going to occur. It's going to electrolyze. This is not dissolving, even though, sure, it does. Okay, so let's go ahead and figure out what will happen. We've got sodium plus and iodide minus in solution. You're applying some current to it. So the things most likely to happen will be the ones with the least negative or most positive reduction in oxidation potentials. And they want the balanced oxidation half reaction. What's going to lose electrons? Well, we've got sodium plus in solution. That's not going to lose electrons. We've got I minus in solution. That could lose electrons in the other direction here, right? To go I2 plus 2I minus, the E naught for that would be minus 0.53. Not too bad. Water could also be reduced, right? Water could give up 4 electrons and turn into O2 and H plus. But that's minus 1.23. That's worse. So I think iodine's going to get oxidized. Iodide, I should say, will be oxidized. That's part little 1 here. Part 2, how about reduction? Well, the first thing is you would think that Na plus can gain its electrons, form Na solid. That's as written, so that's negative 2.71. Not very favorable. What about water? Water can gain electrons, and in fact, that's less unfavorable. That's more favorable, so I think water will get reduced. That makes our overall reaction NaI plus H2O will turn into NaOH plus H2 plus I2. I hope I got all that right. I don't know if they asked for it. They asked for balanced oxidation, check. Balanced reduction, check. Which reaction takes place at the anode, oxidation or reduction? Anox. Oxidation takes place at the anode. Finally, all electrolysis reactions have the same sign for delta G. Well, you're pumping energy into an electrolysis reaction, so delta G will be positive. How do we do? There they are. Delta G will be negative here, sure, because it's dissolving. Positive because one thing turns into two, more particles and reactants. It's an endothermic process because it's favored as you increase the temperature. And by virtue of the free energy formula, this thing could have a negative delta G, especially as T increases. Iodide gets oxidized, good. Water gets reduced, good. Anox, good. Delta G is positive because it's electrolysis. This is AP Chemistry, Energy and Electrochemistry, problem 2005D.